Generally speaking, there's no good way to describe the relationship between a continuous predictor and a categorical outcome. So, when your outcome is categorical, the predictor must also be categorical. Therefore, any continuous predictor variables must be collapsed into categories before conducting bivariate analysis when your outcome is categorical. As previously discussed, the best categories are those that have scientific or clinical meaning. For example, collapsing systolic blood pressure into a categorical variable for hypertension. The variable could be dichotomous, yes, no, or it could have multiple levels, no, pre-hypertension, stage 1 hypertension, and stage 2 hypertension. However, when no scientifically meaningful categories are known, it's common to collapse continuous variables into quantiles. We've already done this using proc univariate. Once your continuous variables are collapsed, you're ready to create in-way frequency tables in SAS that will allow you to describe the relationship between two or more categorical variables. Watch this demonstration of creating in-way tables in SAS. We've already used the frequency procedure to create one-way descriptive tables for categorical variables, so we'll not spend much time on that in this video. The only thing I want to demonstrate here is that the out equals option in the table statement will save the results of your frequency report to a new dataset in much the same way as the output option in the last video. And here you can see a list report of the new dataset that was created. One-way frequency tables can be interesting in their own right. However, most of the time we're interested in the relationships between two variables. For example, think about when we looked at mean height within levels of gender. This told us something about the relationship between height and gender. While far from definite, our little survey provides some evidence that women, on average, are shorter than men. Well, we can describe the relationship between two categorical variables as well. One way of doing so is with two-way frequency tables, which are also sometimes referred to as crosstabs or contingency tables. Let's start by simply looking at an example. Here we have the familiar frequency procedure, but with one key difference. We add an asterisk between variable names in the table statement. The first variable will always form the rows, and the second variable will always form the columns. In other words, we can say that we're requesting from SAS a two-way table of per stock by gen health. Okay, let's walk through this output together. Think of this box as a little legend that tells you how to interpret the rest of the boxes. Reading from top to bottom, the first number you encounter in the box will be the frequency or count of observations. The second number you encounter will be the overall percent. The third number will be the row percent, and the fourth number will be the column percent. Reading from top to bottom, the row headers describe categories of per stock, which are no, only one, and more than one. Reading from left to right, the column headers describe categories of gen health, which are excellent, very good, good, fair, and poor. The bottom row gives the total frequency in percent of observations that fall in each of the categories defined by the columns. For example, about 16% of the class overall reported being in excellent general health. The far right column gives the total frequency in percent of observations that fall within each of the categories defined by the rows. For example, 38% of the class reported that they do not have one or more people that they think of as their personal doctor or healthcare provider. And the bottom right corner gives the overall total frequency in percent of observations in the table. Together, the last row, the far right column, and the bottom right cell make up what are called the marginal totals because they're on the outer margin of the table. To clarify, let's interpret the data contained in the first cell that has data. The first number is the frequency. There are 4 people in our data that do not have a personal doctor and report being in excellent health. The next number down is the overall percent. So, 4 of the 64 people in the data have no personal doctor and report being in excellent health. 4 out of 64 is 0.0625. So, 6.25% of all the people in the class have no personal doctor and are in excellent health. The next number after the overall percent is the row percent. The row this cell is in is the no row. Of the 24 people in the no row, 4 reported being in excellent health. 4 out of 24 is 0.1667. Said another way, 16.67% of the people with no personal doctor report being in excellent health. And finally, the last number is the column percent. This cell is in the excellent column. Of the 10 people in the excellent column, 4 reported that they do not have a personal doctor. 4 out of 10 is 0.4. Said another way, 40% of people who report being in excellent health have no personal doctor. This is a lot of information in one table. But what if we're only interested in some of these statistics? We can suppress the ones we don't want using statement options in our code. Here we use the no call and no percent statement options to suppress the column percents and the overall percents respectively. Often, we want to describe relationships between a variable of interest and several other variables. Instead of typing your proc_freq step over and over, you can put a variable list inside parentheses like this. As you can see, SAS returns a separate two-way table for each of the variables inside the parentheses. The top table is the same per stock by gen health table you saw earlier. The second table is a new per stock by gender table. Notice that per stock is the row variable in both tables. I would also like to note that it is possible to create frequency tables in SAS that describe the relationship between 3 or more categorical variables. These are usually called in-way tables, of which the common two-way table is a special case. All you need to do to create in-way tables is continue adding asterisks and variable names in the table statement. Here we create a 3-way table of per stock by gen health by gender. As you can see, SAS generates 3 separate 2x2 tables of gen health by gender over levels of per stock. A word of caution though, unless you have extremely large data sets, it's easy to get cells that are sparsely populated and give unstable results when using in-way frequency tables. I showed you how to create them for the sake of completeness. However, you will rarely, if ever, actually need them. Here's an opportunity for you to practice creating two-way frequency tables. In this module, we finished performing descriptive analysis. You now know how to estimate simple univariate statistics for continuous and categorical variables. You know how to do this using numerical and graphical methods, and you know some methods for describing basic relationships between variables of both types. We only began to scratch the surface of the options available in many of the procedures we discussed today. There is just no way I can cover them all. However, I strongly encourage you to explore and play around with these options. You're bound to learn some cool tricks that will make your life much easier.